Today I'm going to run through question 4 of the mini mock that you had. And here we have a question which is saying solve for x between 0 and 360 for the equation 3 cos squared x plus sine squared x plus 5 sine x equals 0. As soon as I see something which resembles a cos squared and a sine squared and a sine, I know that I want this to be in some form of quadratic equation, but at the moment I can't do that because of this cos and this sine. In my quadratic equation, my sort of linear term would be sine of x, so therefore I'm going to rearrange cos squared x to be some form of sine squared x. So, using the formula cos squared x plus sine squared x equals 1, I know that cos squared x is going to be equal to 1 take away sine squared x. This is really useful because what I can do now is I can substitute in 1 take away sine squared x into this cos squared x, which would give me a new equation of 3 lots of 1 take away sine squared x plus sine squared x plus 5 sine x, and that's going to be equal to 0. Rearranging this, I'm going to get 3 and then negative 3 sine squared x plus sine squared x plus 5 sine x. So 3 take away 3 sine squared x plus sine squared x plus 5 sine x equals 0. And then simplifying this, I'm going to end up with negative 2 sine squared x plus 5 sine x plus 3 equals 0. The only thing that I have which is an issue with this so far is I want to just make two things which are more sort of quality of life changes. So I'm going to multiply through by negative 1. That's my first thing I'm going to do. And I'm also going to say let a equals sine x. I just prefer looking at one variable rather than multiple. So when I do this, multiplying through by negative 1 would give me positive 2 sine squared x plus, take away 5 sine x, take away 3. So I'm going to end up with positive 2a squared, take away 5a, take away 3 equals 0. Didn't really need that positive there, so I'm just going to get rid of that. And now I can factorise this nicely. It's going to be negative 3 and positive 1, so 2a plus 1, a take away 3. So therefore I get my answers of a equals 3 and a equals negative a half. Now, I know that a equals sine x, so therefore I've got sine x equals 3 and sine x equals negative half. Most of us managed to get up to this stage, but what we didn't realise was that the sine of a negative, a sine of a value of an angle can't be greater than or less than 1 or negative 1. So for this example here, where it's equal to 3, I can't do that. So the only thing that I'm actually looking at is this bottom equation here for sine x equals negative a half. So this is the main equation that I'm going to be focusing on. And what I need to do is find all of the answers for that between 0 and 360. If you put sine x equals negative a half on your calculator, you would have sine x equals negative a half. To do that, you'd have to do sine to the negative 1 of negative a half, but your calculator will only tell you an acute angle, and it would give you negative 30 degrees. Once we get to this stage, we need to recognise that negative 30 isn't between our range, so therefore what I'm going to do is I'm just going to plot just a quick sketch of what my sine graph would look like. So if I have some form of axes here, my sine, it goes through at the origin, so it should look like this. But it also has negative answers. I'm looking for my answer of sine equals negative a half, which is going to be something like down here. So the actual value my calculator has told me is this value here of negative 30. I just need to think about some symmetries here to work out my other values. So I know that sine of negative 1 of a half gives me negative 30. If I add on 360, it's going to tell me this point here, which is 330. So I'm going to get a value of 330. And then if we think about this, it's 180 here. I am 30 degrees away, so I'm also going to get a value of 210. So, looking at my range between 0 and 360, I know that my only answers that are applicable are going to be, let me just change it to a different colour. The only values that are going to be applicable are going to be these values here of 330 and 210. So therefore I would finish off my question by stating that x is going to be equal to 210 or 330. And that would be the end of this question. If you have any questions or you want me to go over something similar to this in class, please let me know, but thank you for watching.